screwed, and socket weld fittings perform the same basic functions as butt weld fittings. Like butt weld fittings, elbows, tees, and reducers are manufactured for screwed and socket weld applications. There are, however, a few differences that must be examined. Screwed and socket weld fittings are normally reserved for installations where the nominal pipe size is 3-inch and smaller. Screwed and socket weld fittings are also available in cast iron or forged steel. Typically, forged steel fittings are used on high pressure and temperature lines. However, low pressure and temperature lines, such as air, water, or condensate, are fabricated using cast iron fittings. Pipelines containing high pressure and temperature fluids, which are subject to substantial amounts of movement and vibration, mandate fittings made of forged steel. For these reasons, forged steel screwed and socket weld fittings are manufactured in two pressure classes, 3,000 and 6,000 pound rating. The sizing chart that you can see here provide the dimensional measurements for 3,000 and 6,000 pound rating screwed and socket weld fittings. For example, the length of a screwed coupling class 3000 mounted on a 3/4 inch pipe is 2-inch. These charts are also available in the downloadable resource section. Now, most screwed fittings are manufactured with female threads, as defined by the American Standard and API thread guidelines. As shown in the following figure, of particular concern to the pipe designer is the amount of pipe length lost during the assembly of screwed fitting configurations. Actually, when screwed fittings and threaded pipe are assembled, as in this example, a certain amount of pipe length is lost. This is a result of the female and male thread connecting process. Each time a threaded connection or engagement is made, the configuration gets shorter. The length of this engagement varies depending upon the nominal pipe size and the pound rating of the fitting. The procedure to determine the actual center-to-center length of threaded configuration is to subtract the total length of all the thread engagements from the total unassembled length of pipe and fittings. The unassembled length can be thought of as all the pieces, both fittings and pipe, being laid out end to end as depicted here. From this unassembled length, the total of all the thread engagements is then subtracted to determine the total assembled length. There is, however, one exception to this simple rule. Why is that? Because some fittings, such as plugs and swages, as you can see here, are manufactured with external threads, and their assembled lengths are treated differently, as will be explained further ahead. For now, keep in mind the socket weld fittings has become the fitting of choice for many fabricators because it offers greater strength at each point of connection. Even though screwed fittings can be seal welded if necessary, strength of the fitting is decreased when the threads are cut during the manufacturing process. Socket weld fittings can be easily fitted and welded without the need of special clamps or track welds, which are often necessary to hold a fitting in place before the final weld is made. However, just like screwed fitting configurations, during the assembly of socket weld configurations, there is pipe length loss. Take a look at the following figure. It provides a sectional view of two socket weld elbows and their connecting pipe. The lost length I'm referring to is highlighted here in red and is actually equal to the depth of the socket and must be accounted for when calculating the overall lengths of pipe runs. However, there is a slight difference from screwed pipe assemblies. On socket weld connections, if you recall, a small gap is factored into each socket weld connection. So, as highlighted here, two socket depths must be subtracted from the total unassembled length of the two elbows and the piece of pipe. Then 1/8 of an inch is added back to account for the two gaps before an assembled configuration length can be determined.